Hello guys, Zaf from AppleFix New Zealand. I have got Macbook Pro A1708, which is quite newer laptop, maybe a year old. And these laptops now A1708 and A1707, they are having problem. They just go dead. So these are like around $3,000 laptop, I think, and even the second hand is around $2,000 mark price. These comes with only with 1 year warranty, which is I think bit unfair to the Apple customers. These sort of expensive laptops, they actually comes with 2 to 3 years warranty. So anyways, this is just dead. So it's not turning on, not charging, nothing is happening. So let's see what's wrong with it. And so this is the board which uh, uh, we have already removed from here. So now it's dead, it's not turning on. So the first thing, these have got type C charging port. So the first thing, if you are a technician, first thing you have to check, because with the USB type C amp meter, you can find out different things before you start working on it. So I will show you here. So type C amp meter. So we will connect on one of these ports. And let's see what indication we receive from type C amp meter. Okay. So as you can see, we have got 5 volt and 0.203 amps, which is not enough to turn it on. There is something wrong. And now to find out where the problem could be, so first thing what I would do is to check type C power management IC. If we find out there's nothing wrong with the type C power management IC, then we will go further up. Otherwise, these are the, from my experience, this is the most common problem on this MacBook Pro A1708 and A1707. So let's look here. I will get the multimeter so that you can see here. Let's see. So the power management IC, which is U3200 and U3100, which is just located here. This is primary, which is U3200, and this is U3100. So do I hear a beep? No. Okay. So this is in continuity mode now. So first thing I would like to check the capacitors, which is one always on the ground and other one is on the line. If I find anything unusual, okay, so as you can see guys, I will remove that. Is this here, this one? Yeah, okay. So I will put a little bit here. So this is U3200. So this line is okay, and now you can see I'm getting beep on both end of these capacitors, which is not right. So let's see what cap is it and where it's attached to. Okay, so this is board number is model number is A1708 and the board number is 820000840, which is this one here. So now let's look at where the Q3200 is. I will just change so that we can get the part numbers here. Okay, so as you can see, this is U3100 and this is U3200, and the cap is I will just go here so that we can get the part number. Yes, I took it. Anyway, are we getting the part number, show position, or we don't worry about it? So this is the cap which we're talking about, and as you can see, this is PP3V3 line, which is, of course, if it's shorted, you're not gonna get anything, you know, your computer won't turn on. So anyway, so this is C3208 and this is connected to U3200. So either, now the next thing I have to check where this capacitor is next connected to, which is the other side of the board and U2890. So before I do anything, I have to examine this area as well. So if you go back here and turn around the board, and I will go here again so that I can check. So this is just close to U2800, is located U2890. Okay, and if this cap is shorted, then all the caps on this line should be shorted. So before I do anything, I would like to check, which is let's go back here and I will move it a little bit here so that you can see. So the next one is this one here. Okay, let's check these caps. This is shorted. This is shorted. So now we have got the problem on P3V3 line, which is, of course, if it's shorted, we're not gonna get any power on the board. So now I would like to examine all these under the microscope and I will share with you. Let's go here, it's a bit dark. Okay. So first of all, let's check here. Can you see? Okay, now it's pretty clear. So this is okay, this is the cap which is shorted, and this is U3200. Okay, so can you see that bit of dot there? So this is the orientation dot and this is something unusual here. I will go closer. Come on, microscope. That's bad. Okay. Yeah. Man, see the, see the hole here? Okay. So the line is shorted, which is coming out from U3200, which is type C power management IC, and and we can see there is a big, not big, but like if you are looking through the microscope, it's big hole here. So something has burned this very expensive Macbook, which is Type C, and we can see the hole is there, which give us a quite clear indication that that must be faulty because there is a hole there. So the next thing I will be doing is removing U3200, which is Type C power management IC. One of the there are two on this MacBook, and the 15-inch one they have got four power management IC because you can charge on any of those Type C. This one has got only two, so it has got two Type C charging IC. So the next thing I will be doing is removing it and then soldering another IC, and then we will see how it goes. So before I remove the IC, I would like to remove the heatsink because when I'm taking IC out, I want less thermal mass. I don't want all the heat, dispense through the heatsink, and I unable to melt the solder balls and remove the IC. I want it quick. I don't want to give this MacBook not more than heat it requires to remove the IC. Should I remove the LCD connectors as well? Should I? I should be. No, it's better. Okay, I think this take. Let's take different screwdriver. So I will remove that LCD connector just in case, Okay, there you go. All done. There are four different types of screwdrivers you have to use. I don't know why they do that. So anyway, so the next thing is I will put some heat resist tape. So I don't want to make it lengthy, so I will stop here and put heat resist tape, and then we will start again. So this is already masked with heat resist tape, and I'll put some flux on it so that it can come out easily. Okay. And I will get the right temperature. Okay. I hope you can get the view, yes. So now we will remove it. This Q3200 power Type C power management chip on MacBook A1708, which has got a hole on it, which I think you can't see because it has to be real close. And once this is taken out, we will examine what that hole is about. Maybe these Type C power management ICs on MacBook Pro are not stable quality, and they are making this $3,000 MacBook Pro gone dead, useless. So I hear a beep and I have already reached my desired temperature. I don't want to force pull it, I'm just waiting when this IC is ready to come out. here. Okay. Now I will just mark the orientation. Which way is it? Where is the dot? Okay, so this is C. I will just put C here so that I remember what the orientation is. So this is reading that way. C. Okay. So let's examine from the other side. I don't see anything here unusual, but only this hole here. Okay, I will show you in the microscope. Let's go here again. Yeah, you can see this is my user. See this big hole here. Okay, now let's see the orientation. So this is a little bit. Anyway, guys. So now the next thing we have to do is to clean this excessive solder so that we can put a new IC. Okay, let's give it a clean. Okay, mate, we will give it a clean. So we have to make sure this is flat, no excess solder balls there, so that the new IC is sitting flat.
Most of them are working.
Okay.
So we have to replace whole keyboard. This one? Yeah. I replace the whole keyboard. I will open it up and check which keyboard is it and give it. Can you read it? Yes.
The middle part is grounded.
So I was gonna get one from AliExpress and then because my weight is a computer. We have to order from overseas.
Okay.
3 to 4 weeks. 3 to 4 weeks. Yeah.
Okay, that's all done. We will clean it with isopropyl alcohol now. So I have removed the heat resist tape because now I would like to give it an isopropyl clean. Okay, it looks clean. Am I happy with it?
Still working on it.
Yes.
On the case. Yeah, so if it goes on here.
No. Hopefully next week.
Okay, guys. So
Yeah.
we removed the Q3200, which is Type C power management IC. Give it a clean, and the next thing I will be doing is installing the new one. Which I would like to put heat resist tape again, because just you will never know. Doesn't matter how experienced are you. Sometimes you will never know where it's more heat in the surrounding area has dispersed and something got shorted. So it's better to be safe than sorry. So I will heat resist tape, and then we will install new IC and see how it goes. And sorry, we forget to check if the short which we have figured out in the beginning, if after removing the IC, if the short has relieved or not, because I was quite confident. So before I put heat resist tape, I will show you here. So can you see? Yeah. Okay. So this was the cut, which was so if we should hear a beep if the short is not relieved. See, no beep, but let's check it that way. See, beep, no beep. So that short has relieved, and this IC was causing the problem. So let's move forward and put the heat resist tape. So this is all set and ready to go, and we will take the new 23200. Oh, come on. Anyway, so this is the new one. Take it out. Let's see if it's all good. And yep. Okay. Yep, that looks all good to me. Okay, and before we put it there, let's put some flux. So guys, if you are in New Zealand and you would like to learn these sort of skills, we offer logicboard and microsoldering repair courses. If you do, you have to plan ahead because we always book a month ahead. Anyway, so and one of the questions guys who called me to inquiring about the course, they ask like they want to learn Macbook or iPhone, what's the difference? So once you know how these electronic components like capacitor, resistors, diode, inductor, transistors, IC, how they work, doesn't matter what sort of electronic board it is. Maybe it's a TV, a radio, a MacBook, a Windows laptop, or Samsung or iPhone. Once you know, you can fix anything. Anyway, so that looks like it's fitting at its right place. So the next thing I have to do is maybe turn on the light, and I hope the orientation is right. Let's make sure. Yeah, the part is there. That's all good. So this is, I have to hold it in the right place, and then right temperature and right airflow, and then it should be all good. So I will hold it as much possible as I think it's right, and then start hitting it. So because after removing the IC, the short has relieved, so we are pretty damn sure that this was the problem, because if there is another problem we will come to know once this short is relieved. There might be something else is wrong. So what I'm trying to look for my um, flux. So I've got here. So I will give it a heat again. So I'm just waiting here now so that the IC settle down. This IC has got a very strong thermal mass. Most of the middle um, connections in which are in the center, most of them are ground. So that's why sometimes these IC they are a little bit harder to settle down as compared to some other ICs. So that looks all good to me. Okay, so we will wait. So now we'll wait maybe 10 minutes so that it's cooled down because board is pretty hot. And then we will check with our type C amp meter what amps we are getting on it, and then if we are getting right amp we will put it in um, the housing and see how it goes. So it's okay now for me, not hot anymore. So first thing first, we have to check if we still have short on the same cap or no. Which is this one here? This is ground, this is online, so no short. Let's check on the other side where this was connected. I forget, this is here, no short here, so that short is relieved. But okay, let's check with the type C amp meter. So we were getting only 5 volt before, whereas this should turn on 19. Let's put it here and see what we got. So can you see? Can I see? Oh yeah, 19 volt. Can you see? Okay, you can't see. Let's maybe turn the light off. Okay guys, do you see we are getting 20 volt, which is the right volts. Before we were getting just 5 only here, and 3 amps, which is also right. So now this board is fixed, but we will put it back. So we are getting now 20 to 19 watts, which is the right watts on these MacBooks. So it should turn on now. There is no any other problem I see. It won't. We'll put it back together and test it. So the board is there. There are lots of screws and cable which these MacBooks we have to do anyway. So yeah, so I can. Okay, let's put that amp meter again so that you can see here. I think you can, yeah, that's better way. Okay, let's now see how it goes. Okay, so it's taking 19 volt, that's all good, and let's turn it on. Okay, fan is spinning, started spinning, no display. Oh yeah, there you go. That was quick. Just looking at my text messages. Anyway, so So if you have got any MacBook, which is any MacBook, but these are quite expensive. Even if you're buying secondhand, they are around still $2,500 mark. And just because of the small part, and you have taken it somewhere, and they say no, it's not fixable, you should try us. And I will leave a link if you don't live in Hamilton, New Zealand. If you live anywhere else in New Zealand, not in Hamilton, I will leave a link how to send it through in the courier. And that's all done. So that's another successful repair. Thanks for watching. Bye.